Okay, so now we're recording the conference call. So welcome to the True Fans. This is our monthly True Fans Hangout to find out pretty much what the latest ongoings are with the organization to get people more closely involved with the project. So this time around, I want to start by an overview of where we are as the organization, kind of like the big picture view of what the goals are, the major vision, which is really on a 20-year time scale. So I always like to introduce the project with what we're really after in the big picture and dive into the back to earth to where we are right now and how we're trying to get there. So the theme for where we are as the organization these days is really about developing working teams and disseminating distributed enterprise, basically efficient economic models that can be replicated throughout the world. So starting with the big picture vision, we'll start with the True Fan Hangouts as a broad scale discussion on the state of the world as seen through the eyes of open source development. And open source to us means unbridled transparency, sharing of information, collaboration. We start with the big long-term ideals, such as creating the open source economy. When we talk about the mission of Open Source Ecology, it is to create the open source economy, which, if you look at today's economy, that's $100 trillion total. Our goal is to, within 20 years, cause about or be essential to creating about 5% of that, converting about 5% of that into the open source domain, which means that there's a significant foothold of open source within the economy. And so 5% is about the level you would need if mass adoption is going to happen. It's basically the early adopters, the thought leaders. If we feel that if we have about 5% or so, like according to transformation theory, then there's enough motion around, enough energy around the effort to make it scale in a much bigger way. So at that point, we have kind of like a battleground being fought where we can see, okay, are we showing that open source is a way to go forward and it's producing effective economic results and making everybody happy, or we continue in the current course, which is pretty destructive at present, the scarcity economy, where as we're going today, there's a lot of environmental destruction and instability that can be a significant threat to human survival even. So that's a real thing a lot of people are concerned about with, for example, on farmland. If you look at farmland degradation, did you know that in the United States, the average for all agricultural land is that 5 tons of topsoil are eroded per acre? That's mind-blowing, but that's the current fact, which indicates that in 100 years, if we keep going this way, we're going to and perhaps collapse. But we don't want to go there. We want to create an abundant post-scarcity economy. Now, in today's economy, competitive waste, protectionism, keeping others down, not really cooperating. That's how we make money. And by necessity, that tends to keep people down as true education, true empowerment is not happening. And in some way, we're replacing best practice with enforced mediocrity, simply because people don't share. And that's one of the big challenges we're trying to address. Thinking about big picture, very important economic sectors like agriculture, some key enterprises there, like a sustainable farming operation or an aquaponics greenhouse or a tractor or various technologies that can have a huge impact. And it's more like product systems that we're trying to work out to make them better, that they really spread and distribute economic power to many people as we open source the plans in what we call distributed enterprise. And distributed enterprise is the concept that we share not only the technology but the blueprints very openly, so that we don't promote mediocrity by basically keeping it to ourselves, but by sharing it with everybody. And it's a tall order. You need to have the best product to make it go. So back to Earth. Let's talk about where we are on the concept of distributed enterprise. So at present, we've got about 18 or so prototypes of different machines, and currently working on taking 3 of them to real product releases. And that is, if you actually look at the schedule page on the wiki, if you go to opensourceecology.org/wiki, there's a schedule page which shows some of the workshops we'll be doing this year and some of the developments we'll be doing this year. But three products are in the pipeline, and that is the house, the brick press, and the 3D printer. Those are ready for much market with amount of development we have done. And we more or less snuck in the aquaponic greenhouse in our dog food nature of necessity, because for one, the recent microhouse that we built using our brick press, we found this winter, and so I live in this microhouse, we found that it's rather cold. We need to burn a lot of wood, even though we have a very efficient hydronic in-floor heating system. So we're looking at putting a greenhouse on the front to capture heat and to produce food. So with that said, we can say a little distracted, but not really. You can say that it's feedback. Okay, we need to keep working on a microhouse, and to make it much better in a cold climate, we're adding the aquaponic greenhouse. Now go ahead.
I have a question.
Go ahead. Yeah.
With the latest build, did you look at solving external insulation in a really robust way?
We got a decent insulation system on the latest microhouse. What we did is use 2-inch insulation on the outside. Basically, there's the brick walls 1 foot thick and 2 inches of insulation. With issue, it's R20 for 2 inches of the foam insulation, and there's wood planks on the outside. But altogether, 20 plus about 6, like half R value of 1/2 per inch. So the 12-inch walls get you another 6. So it's like R26 for the walls. So that's decent. The front of the microhouse, though, is not well insulated. One side has 1 inch of insulation, and the other side actually doesn't have any outside. So that part is actually quite cold. Adding the aquaponics greenhouse will help that tremendously. So the good news is we went to a conference. I had a keynote speech at the Permaculture Voices 2 conference, and that was March 4th. During this, we took a chance to collect a team of collaborators on the aquaponics greenhouse. It was actually a very amazing result, because we were able to capture 120 people who signed up to participate in some way on the aquaponics greenhouse, and 30 of them appeared the day after for an initial meeting. That was on a Saturday. My talk was on Friday. So 30 of us got together to start talking about how we deploy this aquaponic greenhouse, and you can actually see that if you look at the wiki. Let me put this link into the Pirate Pad. But the link there is the aquaponics greenhouse working group. Let me put that link in there just to see what the latest is. There's a video there that shows the 30 people basically introducing themselves as far as what they can contribute and how they're interested in the aquaponics project. It was an interesting exercise in pretty much crashing a conference to, if you may, to pick a lot of subject matter expertise. And we talk about expertise. There's people who are experts in everything from integrated pest management to actual past builds of aquaponics. There's some mushroom people and others, and definitely people on microgreens, micro nursery for perennial fruits and nuts. All that kind of expertise came into this team in some way. So that's the aquaponics greenhouse working team right there. I pasted that into the Pirate Pad. You can look at more of that. Now, with that team, right now we're pursuing the team forming state where we're talking to some of the people who showed up and developing leadership within that group. If you look at if you look at that link that I just sent, you can see our model for development there. In there's a disruptive development presentation there that shows a little bit about the development technique we're trying to pursue. You can see some of the videos, and the orientation and success metrics presentation on the same page shows you the overview of the development process, where we have an intro meeting, then we start forming teams and paying a lot of attention to developing leadership for the teams. So as far as the leadership, we're trying to, we sent out a survey to all the people in the working group to pick out those people who might be interested in leading certain parts of the project. So we're currently interviewing those people and forming this team for our kickoff. But that's a work in progress, and an exciting example of having a lot of subject matter expertise, like 120 people who signed up, which means the biggest team so far to date in OSE's history as far as how we can go rapidly in development. So that's pretty exciting news. Okay, I'll move on to the brick press. Now, the brick press is our first ever machine that we built. Well, actually, let's see, brick press. Yeah, the brick press was before the tractor. That was the first machine ever built, and we're at the phase where we have a really good handle on that. And the latest news actually is there's some people in India who took the brick press, replicated it, and are actually looking at, they're working with the government, and they're looking at putting a brick press in every village in India. So we're actually going through quality control and production development on that. So it's very exciting. And our goal for April is to the month of April, work solidly on the latest blueprints to release the brick press. And we'd love to see between 100 to 1,000 replications happen within a year from the final plans, because we're trying to make it really easy for people to replicate, get their hands on the plans, where they could either build the machine themselves or send it to a local fabricator. So the case of some just downloading the plans, taking the plans, working with a local fabricator to build the machine for themselves or for somebody else. Now, the next project that we're trying to release is the 3D printer. So this is what Andrew and I were talking about just before. But the concept is to use basically 3D printers. The RepRap project is very well developed in terms of the technology that they have available, and there's many 3D printers out there. The current market for 3D printers is growing like by 100-200% per year. About 200,000 3D printers are being built, and pretty much all of them are a result of the RepRap project. Even if you talk about MakerBot, who took RepRap's stuff and pretty much patented it. But pretty much the 3D printer is a great example of how open source has succeeded in getting a huge amount of economic activity, and it's a market that's growing hugely. Now, we're interested in that because, one, it's a great workshop opportunity, and two, if we create workshops where we teach people to build them and build, say, a couple dozen, say 24 printers in a week workshop, then we can talk about producing armies of people who can prototype parts for us using scale modeling. So that's very interesting for us. Imagine having a remotely by doing 3D prints of parts and scale tracker models or scale brick part models, where it's actually very useful. For example, with a tractor, sometimes it's very difficult to see how parts fit together. Like, you can't get a bolt in. Well, you can test all of that out using a 3D printer. You can print every single part and put it together as a scale model to see exactly how it works. So it's exciting. So for the 3D printer, we're considering two right now. We've been involved with the Lulzbot, which is the open source 3D printer company out of Colorado, Loveland, Colorado. They're growing rapidly. They've got an excellent 3D printer. They've just introduced the Lulzbot Mini, which has automatic bed leveling, which means it calibrates the machine automatically for you. You never have to mess with that. That's one option, and I actually got the Lulzbot Mini that I've yet got to test here. They're waiting for us to test that. But the other option is another replica of another project, the Ultimaker. There's a clone of Ultimaker, which is another great 3D printer. It's actually got the highest market share in the pseudo open source 3D printer world. They have over 10% of the overall market share, and they're based on an open source design. They're mostly open, but not really. But some other people have cloned their machine and put a fully open source version of that out there, and that's they actually called the Troublemaker. not the troublemaker, it's the troublemaker. We're getting a lot of noise back there. Can somebody maybe mute themselves? Or maybe, let's see, to mute yourself, there's you can hit a button. Let me just tell you about that. Yeah.
I can do that on Redtail.
Let's see, it's not through Reptel, it's actually through the, let me see if I can click, I can actually mute everybody as I'm talking here. That might be.
I think I figured out how to mute myself. How's this sound?
Yeah, that sounds much better. So I don't need to mute anybody. Okay, so the one option is the Lulzbot 3D printer. Another option is the Troublemaker, it's called. Now, the good thing about the Troublemaker is that, to me, it appears to be the farthest along. So the guy who's behind that is Mustafa Luka. He's a Shuttleworth Fellow. He is from the Karuza project. That's a project that's developing a 1 gigahertz optical internet link, fully open source. Great guy. The good part about that is that he has built 100 of these, and he did that through 4 workshops. Each workshop produced about 24 of these 3D printers. So they have well-documented plans for how you can build one of them in a workshop setting with 24 of them with, I guess, 1 person each. But they do that in 12 hours. Great. That could make for an excellent workshop. And they have that pretty much down pat. So we're talking to them right now, and the next step is assessing those designs, and he actually wants to make several improvements on that based on what they've learned, just a few refinements that are going to make it even better. But that's a nice design. The advantage of that design is that the bed is still, and the print head, that's the only part that moves. So it actually makes for very stable, fast prints. I haven't really compared directly to it's an excellent printer, and it's an option that we can do. So the way to spread this project is to generate economic activity around it. And what are the economics looking like for the 3 projects I mentioned: the aquaponics greenhouse, the 3D printer, the brick press? So let's start with some speculation on the aquaponics greenhouse by studying the industry standards of production. For example, such as lettuce production, which is conventional lettuce production done in hydroponics. The yields there are $1 per square foot per week, which means a 2,000 square foot greenhouse like that would yield you $100,000 of productivity per year. So that's about a figure for our goal for a 2,000 square foot greenhouse. Our aim is to develop a $100,000 per year model with payback time of under 1 year. So the thing has to cost under $100,000 to build. Now, what we want to include is fish, a mixture of various crops from lettuce, many other ones. And then we were discussing mushrooms underneath the grow beds, and a third layer, which would be pretty much above the regular growing beds, more like in the air at the second story, would be more channels for more plants. So we're working on that currently, but we think we can get $100K net per year. And the key to that is going to be the integrated pest management aspect, because once you get an intense production like that, with diversity, you're going to have bugs, basically open source bug farm, beneficial insects that would allow you to do this. So high level of integration. The mushrooms produce carbon dioxide, which the plants lack. So carbon dioxide being a limiting factor for growth in an intense growing environment. But that's an exciting option. If this works, our theoretical goal is to spread 100,000 of these within 5 years of developing this full plan. That means $10 billion of economic activity distributed to many, many people. The goal is to publish the blueprints, train people, in the fashion of a distributive enterprise, or trying to distribute wealth far and wide among the population. That's the general idea.
Martin,
there.
I have a question about that.
We're in the middle of that. Go ahead.
I'm wondering if people wanted to collaborate remotely, how could you envision that working most efficiently? If I was to do something like that here in Byron Bay, I'm just concerned if I was to do similar things that, resources could be wasted. So I'm wondering if you have any ideas around that.
What I would suggest, and that's exactly right, if you get a working prototype, you don't want to have build two things that do not work. Now, that depends. If you guys have some resources and it's cheap enough to do it, or you get somebody to sponsor that with the intent that we know that it's going to take several iterations before we're going to get it right. So it would help if say, two of them are built. However, that would be worthwhile only if we have enough expertise and proven track record of things that have been built already that are similar, that we can say, hey, we should do it because we're pretty certain that a lot of it is going to work and we're just going to make refinements. Now, this is true. So one of the collaborators in that group, Ori Paz, he's actually done a build with another project called School Grown in California. He's built an 1,800 square foot aquaponic greenhouse like that. So we can essentially start by copying that and building upon the experience from that. So in a particular case like this, it would be rather recommended that a couple of projects could do the same thing. Now, what we're going to do here at Factory Farm, we're going to start with a smaller 800 square foot version. Maybe the wise thing to do would be to, I don't know, maybe you guys want to build a smaller version and then build up to a larger version, or perhaps do the bigger version in parallel. Now, we have considered that in the sense that we are putting together, or want to put together, with the business development side of that project, what we call a proposal construction set. That means some of the technical assets and media assets that you can put in a proposal to submit to a local foundation or so. So basically, we'd like to promote that if you've got a local community development group, foundation, or somebody that might be interested in funding this, we'd like to make that easy for anybody that does that. So we're hoping that would actually help in the replication co-development process. Now, we're looking at it as creating an open
Hey, what's going on there? Understand. Yes.
Hi, it's Martin. Do we still have everybody there? Andrew, you there? Do we still have Stephen?
Welcome. This service is provided by freeconceptall.com. Please check it with us.
Okay, it's Martin.
Some trouble here. You guys still there?
I'm here.
Okay.
Definitely.
Do we have Stephen still? Okay. Yeah, I'm sorry. My computer has crashed, which was not a good idea to call through the computer. So let me see if I can record this. I would like to continue recording here. Okay. So you guys okay? Can you hear me?
Wonderful.
Okay. Excellent. So I'm just going to continue a little bit more about the formal, what I wanted to talk about today. Okay, we're talking about, I left off, remind me where I left off. What was the last you heard? Andrew, you still there?
Yeah. Sorry, I don't know where you left off actually. I think we're talking about aquaponics. We're talking about having a working model somewhere in a lighthouse. And
yeah, right.
From there, soon after I lost you.
Okay. Yeah. Good. So the question was, getting back to the conference call, question was, is it worthwhile to have several people prototype, do the actual builds in different parts? And the answer would be yes, if the actual aquaponics greenhouse is well developed. And that happens to be the case here because there's a project that's built of this nature, and they're willing to share that. That's it's called the School Grown Project. It's out of California, Half Moon Bay in California. It's a school, but they've built an 1,800 square foot aquaponics facility that's currently operational, and they're willing to share that. They're willing to cooperate fully. So that's very interesting. And we talked about the possibility of doing a proposal construction set where other people could apply locally to their local foundations or crowdfunding or whatever to make this happen. So the way we'd like to roll this out is by creating an open consortium of several leaders or organizations that want to do the development on this, and we collaborate with understanding that this is all going to be an open source model. That's pretty much all that I have on the aquaponics for now. I'll move into the brick press and 3D printer economics. So with a brick press, what we'd like to do with it is create both a way for us to sell it pretty much by using our local fabricator in our town, which is a model that others can replicate. You can take the blueprints, you can have a local fabricator build it. And if that's done super efficiently, it would probably take between 4 and 16 hours to initially a little more time, but eventually about 4 hours or so in an optimized way to match one of the machines and then sell it at a markup. So there could be several $1,000s of profit in a transaction like that if OSE, for example, sells the brick presses, and that's something that could be replicable. Basically, taking a markup upon a product that's sold. That's one way to go, and we'd like to do that. We'll see how far we can get, but if we can sell a few machines that way per month, that would be awesome. I mean, imagine we make say $2,000 to $4,000 per machine, so a few machines would be $10,000 or more per month that we can generate for bootstrap funding the project further. So we're trying to explore that. Now the second part is if we run workshops like we have done last year. In one workshop we sold a machine for $5,000. We generated about $5,000 revenue from tuitions from the workshop, so that one build event over a weekend could net us $10,000. Now we'd like to train people to do this. We don't have people that can do that, but in order to bring the production of the brick presses and other machines to other locations, we want to train people to do that in different places. So the earning potential there is good. Now for the 3D printer, the general model was to charge people a little bit over the base material cost, something like $300 for an immersion workshop over a weekend where you learn everything about the machine. You get an immersion in how to build it completely and manage it and do printing. So imagine we charge about $300 per person if you have 24 people show up, and it's demonstrated by the Caruza project, by the Troublemaker 3D printer. They could build 24 in a weekend or over a 12-hour period. So that could be a business model where 24 people times $300 for admission would get you $7,200. So imagine running one or a couple of these workshops, that'd be revenue to bootstrap the project. So that's where we are right now. These are some promising technologies that we can develop to the finish line. And the I think the main thing when we look at this is having a solid core of product that provides the substance for making a viable business. And with a brick press that's there, with a 3D printer that's there, and we're working on it with the aquaponics. But those are all proven models that we're just simply trying to optimize as potentially large market items. And then the brick press, I mean, selling the brick press itself may not be as large a market as actually building the houses with it, of course, and that's where we'd like to get to next, where we develop the model for how you build a very low-cost, high-performance house in a workshop scenario. So imagine we have clients who buy this service. You can think of it as a product service system, where we come in, we build the workshop, build the house. The person pays us for the materials. So basically the person covers their materials for the house build. We organize a workshop around that. And that way, essentially at the cost of materials, a client would be able to get a house built. Because people like us, OSE, we could charge admissions from the education part of that. So we're trying to innovate on whether this kind of model is possible. And we've had decent results last year in the various workshops we did have on the microhouse build. Those were fun, immersive workshops, especially the microhouse 4, where several comments were like, wow, I never knew I could do this and get so much done. And in that case, we actually combined modular standard frame construction with brick, super solid, large thermal mass. So we were able to, over a 5-day workshop, pretty much build most of the house. And we had to do a lot of finishing on the inside, but the whole shell, the roof insulation, and some of the siding was pretty much on as a result of the workshop itself. So pretty good results. And just trying to get that to higher level of evolution, build upon that system for the aquaponics greenhouse. We can use the same modular type of construction on that. I just went through the numbers. A 2,000 square foot shell, including double wall polycarbonate glazing, would cost us about $8,000 in materials using our existing techniques. So that's pretty decent. That's $4 per square foot for a nice greenhouse. Then you can talk about all the other systems that go inside, but relatively decent cost on the greenhouse itself. Now, eventually, if we have our own bioplastic extruder, we can take recycled plastics to extrude our own glazing or do other things. But at that point, we'd be talking about much lower costs of the structure itself, just one by one, developing the additional pieces of the puzzle to make it happen. The interesting development for now is seeing how in terms of the collaborative development, how the aquaponics team works out. We're in the middle of creating that team, so maybe next month we can report much more on how that's coming along, whether that's producing very nice results of a solid model, solid technical development happening on that in rapid time as we're developing the leaders. The basic model is we're training the leaders, trying to find the leaders with a goal of finding like 6 to 12 of them, and each of the leaders would have their own working team of like 6 to 12 people. So in effect, we're working like with a 100-person team by working directly with leaders who then lead their own teams to rapid and fruitful. And the question will be, how do we motivate people to do that? I think one of the first things we can use is a nice infographic that shows the economic potential of this, how, basic description of the systems inside there, so someone can look at it, oh, wow, it's amazing. You can generate so much value from a project that's going to cost so much. So we're trying to generate those assets as we go forward. So I think I'll quit right here in terms of the official program for what I wanted to talk about. We're in the middle of a lot of things, and basically the biggest challenge is right now, how do you get, without creating a big centralized organization, how do you create an effort that can produce significant technological results while becoming just pretty much distributing that freely, while catching the continued feedback and development from a lot of contributors, so that people don't just end up defecting and just going on their own, but actually collaborating to a common pool of knowledge that we can manage. So there's a lot of different requirements for that, including the web platform to do that. the technical development process, documentation, forking, versioning. It's an overall difficult process. We're hoping that by the end of this year we'll have much more insight and perhaps actually a much more refined platform. Right now we're just using pretty much Dozuki as a graphical index of our work, using the wiki, using Google Docs. Pretty much wiki and Google Docs are our mainstay at this point, but we're losing a lot in terms of being able to version and do forks and do pull requests, basically the kind of stuff that software does, where they can absorb contributions from the outside back into the project. That's pretty hard. We don't know how to do that yet. So with that, I'll just like to open it up to
on that note, there's two apps that I've been introduced to recently that I think would be worth trialing over there. And that is Trello as an organization platform for being able to drag and drop people on tasks and agilely move things around. And another one is Slack for communication, which is basically like
Slack?
IRC. Yeah, Slack. It's very accessible though, and it basically, once you've installed it, a bot handles all the questions required, and you're pretty much good to go. You can create your own room, so you could have your aquaponics team, and you could basically have communication channels within your Open Source Ecology page in Slack and Trello. I think they're definitely worth a look at. I'm using them at my startup incubator where I'm doing a course right now, and I think they're pretty effective when they're used properly for organizing everything from events to tasks to just random communication between people.
I'm looking on Wikipedia. It's they raised a lot of capital. You got like $1 billion valuation. So it's on one-on-one messaging, private groups, persistent chat rooms, direct messaging. Those group chats organized by topic. Slack integrates with Google Docs, Dropbox, Heroku, GitHub, Zendesk. That's pretty compelling. So say we have a development project on there. Is there a way does it actually let you keep information there like a wiki, where you're actually using that as a document? Or I guess I would have to take a look at it.
Yeah,
have you done quite a bit of that?
We normally link to Google Docs outside of it, but once you can create tasks with checkboxes, you can drag and drop other users to assign them to tasks, so it's quite clear to see what should be happening. And I think it seems to be quite nice the way you can move things around, shuffle your timelines around. You've got clear tick boxes for progress, and combined with Slack, which is more like your direct chat communication board. It's designed to get you out of email. So if you've got all of Open Source Ecology, your entire network in Slack, and you've got people out of email mode, I think it would really open up the communication for any designated.
Oh, wow. So you're thinking that the email communications, there'll be chat rooms that are pretty much keep the track of the conversations?
Yeah, and you can obviously have private chat if people need to open up, direct lines in there. But it also lets you keep any of your open communication, say, related to the aquaponic system in general, that people can observe that.
Yeah, I like that. How would you suggest using it? Just online, sign up for it, and just start, test it maybe with the aquaponics team? Is it embeddable? Can we embed it in other?
You'd create.
What's the business model?
Well, I think that all the basic functions are free. I'm using it in a free capacity. It seems to work really well. I'm not sure at what level they start to charge to add extra features. But it seems that the basic feature set is pretty good as a start.
That sounds pretty good. Should try it. Just try it for. That came up. Maybe Jonathan. Maybe I'm not sure. Let's see. Do we still have Stephen Wynn on the call? Maybe not. So nobody else is on. I think we dropped a few people. Okay. So yeah. Okay. I'll look at the Slack and then definitely just sign right in. Sign up for it. Open Source Ecology OSE.slack.com. How about that? Your email address. Okay. Yeah, so I'm gonna have to sign up for. What else, Andrew? What are some other thoughts? So, with respect to the 3D printer, what are you looking at then?
I'm gonna dive into our multiple options that we have for doing builds. And I mean, at the moment, I'm quite attracted to the TAS because if you were to do a build and suddenly a new version would be released, it's more upgradable. It's very upgradable. Also,
the TAS Mini. You think the TAS Mini, or are you talking about TAS 4?
The large TAS.
Large one.
And I actually do believe that with some of the advice I've had around, some of our concerns around bed leveling are a little out of proportion, because I've seen people build 3D printers where bed leveling is just not an issue for them. They don't even have to think about it. Once they've got their printer operating correctly, they're done. So I'd like to explore doing a build of a TAS with Michael, who's a local ninja who basically wrote the instruction manual for calibrating all these things. He's achieved things with 3D printers I've never seen before. And I'd like to see if we can get good results with the TAS in the right hands with the right knowledge, then it might be a good way to go.
So you're thinking you're going to be cutting your own tubing, the aluminum extrusions, and just pretty much print out as many parts as you can?
Yeah.
Do you know the bill of materials cost on that?
Not yet, because this has just been realized last night.
Yeah. No, I mean, that's great. We love Lulzbot. They're a great company. They're growing, so they're part of the team. Yeah. Jeff Moe is a true fan and he's donated a couple of printers to us. That is a good idea. And how are you going to track your info? Do you have any place? Do you have a wiki or anything like that? Can you maybe put on our wiki? Just continue that on your log or something like that?
Yeah, let me have a think about that. Log's a good place to start.
You can start just so we can. I know you kept a good log before. Yeah, that's good, and especially with this. So your intent would be to share the model itself, meaning if you develop this for pretty much like production on a scale of, you're thinking what, workshop scale, so a dozen or 2 dozen?
Yeah, workshop scale. We got three teachers. We could maybe go to 4 teachers with 4 students per teacher maximum. That's 16 total at the moment.
So are you trying to do this as a immediate revenue generation opportunity?
Yeah, that's right. We're just trying to figure out if it's viable and with minimum resources to see, and also try and get a feel for whether or not people want it. So I think also I'm going to create a web page to see if people can express interest, and see if we can actually create metrics for success.
Yeah. As far as your other priorities, is this your main priority at present? You're trying to commit your full attention to this to get this going? Or do you have a whole bunch of other things on your plate?
This has currently taken first place as number one. Previously we had the makerspace being number one, but I'm now not so sure about whether or not I could actually create the makerspace and have a viable model for revenue. I could certainly make it stable, but I've decided that unless it can generate revenue to fund open source hardware, that it would just become more of a distraction. Most makerspaces I've seen that are successful are in highly populated areas and not in small towns like Byron Bay.
Are you hoping that the 3D printer revenue model would get you the funding for open hardware development?
That's my intent, yes.
That's good. And how far are you from a bigger city?
Sorry, can you say that again?
How far are you from a bigger city? Do you have enough? Would you take this into your biggest or would you run workshops where you are?
We're 2 hours from Brisbane by car, and we're 2 hours from Sydney by plane. We could potentially move around in the future to, we could do builds in hackerspaces in Brisbane, Sydney, Melbourne.
Tell me your city again. I want to look it up on a map.
My location is Byron Bay, New South Wales.
Byron Bay, Australia. Do you know Juice Rap News? They're from Sydney. Do you know who those guys are?
What was that?
Do you know who the Juice Rap News are? They're a political group. They're from Sydney. You should stop by and see them.
I actually couldn't hear the name there again. You dropped out.
They're called Juice Rap News.
Oh, Rap News. Yeah. Actually, a guy I share an office with actually has filmed. He's editing and filming video for them. We know them quite well.
Oh, no kidding. Very nice. No, I emailed them saying if they ever need to do an episode on open source development, we can help them with technical information.
Excellent.
Yeah. So I see you're 2 hours by car from Brisbane.
2 hours by car from Brisbane, and 1 hour from Gold Coast or something like that.
And that would have plenty of market for. Brisbane is what, 2 million people?
I think around there. Yeah, it's been a while since I looked at the population.
Oh, this is excellent. So, yeah, actually 2.04 million. It's a big market. Yeah.
Once I get to the point where I've got more accurate numbers on our various build options, and I've created a website to measure some metrics, perhaps we could post it on the OSE Facebook page.
Definitely.
To see what our Australian followers or anyone else would be interested.
No, definitely. Let's do it. I'd love to publicize that on as long as it's an open project, love to publicize it on the Facebook and all that. But yeah, if you don't mind, I mean, it would be nice to share your latest progress. If I could follow that somewhere, if you wouldn't mind just logging that on your log, that would be great. See, last time it was 28th of April, 2014. Yeah, that's great. When you were here. Yeah, that's excellent. No, I'm glad this. And if you go forward on this, then let's look at the numbers, because I'm meeting with Mustafa Luka from Karuza actually tomorrow. Oh yeah, tomorrow we're going to discuss some of the numbers on his 3D printer. It's a little more expensive. His bill of materials is going to be more like 900 or so US dollars, but of course there's always optimizations of what parts you select. So I want to take a look at more closely at those numbers. But how do you? So for example, on the issue of the instability for a tall columnar object on Lulzbot, how do you address that? What's your current strategy? Of course, you can print multiple ones and webs between them, but is that what we'd have to do?
So once you get to the full height of the table, you can either go slower, or you can also improve the rigidity by having a more solid frame, and making sure that you're definitely on a really solid table.
I see.
But one of the other things that is often missed is the calibration for the amount of plastic volume that's going through the head. So actually doing a really accurate measurement on what the feed rate is and what the output is, and basically once you've figured that out, if you look at Triffitt's calibration guide, Google that, you'll see his guide on how to get this right. And it's basically about being able to figure out, if I want to put out this much material at this much speed, how do I tune that to within 1 or 2%? How do I tune that within 1 or 2% to actually get so that the computer's actually pushing through exactly what it thinks it's pushing through? And there's different delays for different speeds. So when you're printing at a different speed, you actually do have to do that math and tuning all over again. And it's going to be a little bit different for every printer.
Yeah. Are you thinking, was your model like what I mentioned about the numbers, say 24 people show up for a workshop, you would charge them, say, $300 on top of the bill of materials cost? So you could make, say, like $7,200 for an event?
Well, we were originally thinking, $400 for a 3-day course to do a build, and that would also, and then additionally the machine would be sold at the current market value. But it would be great to actually make it, it'd have to be lower if we're doing something like a WildSpot clone.
So you would actually sell it to the person that made it, or to another person?
No, you could sell it to another person, and
but do you think
made it would have the option to buy it? But I think that they'd probably realize that a 10% discount on the full price probably isn't worth it, and they should just go and do it again by themselves. Because if you sell them,
how much thought did you give to this? This sounds like a person. I mean, you probably want to give more to the person, since they're paying $400 just for education, but that education you wouldn't want to just sell it at the bill of materials. You want to make some more revenue from that.
Well, they have the option to buy the printer at the end, but if the thing is that if you're using it as a production model to sell the 3D printers, you wouldn't want to give them too much of a discount. Like, you probably go to 10 or 15% at the most.
I mean, that makes it 10 or 15%. Because how much did you think about this? You think this could work? It seems to me like, I mean, that's like charging people way too much for that. You don't think so? Or have you tested this model in any way, or got any evidence? Or
No, I haven't tested this model. I just think that if you knew how to build a 3D printer from scratch, and you knew all the ins and outs by the time you'd gone through this boot camp, that the most attractive solution for anyone would probably to go and do it with all the materials at cost price. So we could again sell them the materials at cost price, and so they could walk away and do it again, and we could offer them support. That could be another possibility.
I see. So you're thinking that your value proposition is more like your entrepreneurship training, less than just user training. Is that how you're picturing it?
Yeah. So it's like, I mean, it's similar to how you do the brick press. I mean, everyone that attends that build, they don't get to keep the brick press. They just learn how to do the build.
Right. But because they built their own printer, it's like...
It's not their own, though. It's like, that's the teaching model. They could have the option to buy it, but I think that it should be approached in a similar way to the way that you do the brick press.
Right, they have an option to buy it at the cost. Yeah, so you would do the same model as the brick press, essentially. So the question would be if people, the only question would be, is there demand for that? Are people willing to pay that much money for it? Now, my take on it would be if we're really giving them the skills for like the deep skills that are required, I think that would be worth it. But what I'm seeing happen potentially is that it takes so much time to build it that you get little time for the more in-depth study. What are your thoughts on that?
Yeah, it's certainly possible. I mean, when I talked to Trifford about this, his name's Michael, he felt that it would take 3 days to do a build, and to teach a person how to get full knowledge on how to tune a printer for high performance, he would need 1 to 2 days to do that as well. So we were thinking that if you were to do this, maybe even as a Kickstarter, you know, you could have different tiers, and at 400 you'd have the full build. At 200 you'd have just, say, a tuning course, which is a 1 or 2 day course. And at 600, you could have the full day build. You have the full build and the advanced tuning course as well. This is just these are just some possibilities that we sketched out. Because he said that to show people what happens to tune a 3D printer for performance and to catch all those different situations would probably take about 2 days, and that wouldn't be including the build.
Very interesting. Michael, are you guys on board with respect to opening up that knowledge, or are you guys going to publish that, or
yeah,
you're just going to keep that?
He's very excited about that. I mean, he said all his instructions are on the web for free. I mean, he was saying the Lulzbot team, if they knew that he was running this, they would be all about it. That he said that the Lulzbot guys are well aware of who he is.
That's great news. Yeah. Now it's still just regarding the tubing for tractor prototyping. I still say it will be a significant compromise unless you can print a more rigid structure, but it would double the time if you do go to two. Because what we did in that case, the tubing was actually 1 layer thick. But so if you're going to double it, you have to go to at least 2, which means double the time. So I don't see how you can...
Wait a second. Are you talking about the tractor? Did I hear you say tractor?
You heard me say tractor tubing. Yeah. 3D printing the tractor tubing. Yeah. No, just the plastic scale models. Yeah. So, yeah, I mean, there would be challenges, definitely. But, okay, so I'm excited. I'm really glad you guys are doing that. That's a great... I think that would be... Imagine if you guys succeeded on doing a replicable model. I mean, we're in that game. I mean, personally, I feel that economic potential is just huge. It has the chance to go viral, meaning thousands of people now are producing more printers than the centralized corporations. So I would like to see that, which would I mean, the effect on people. Yeah, I mean, the effect on people is getting so many people out there getting experience hands-on, and that opens up their mindset on how capable they are, because everyone's pretty much suffering from a feeling of powerlessness. So this would open up the mind of many, many people, and that could be transformative. I mean, definitely for those. I mean, it's definitely transformative for the people. It can potentially be disruptive to the... But Yeah, very good. So let's keep talking about this. Keep me informed on your progress. Do start your log. I want to keep track of it. As soon as you guys got anything, like, I mean, even if you got the initial, I mean, just to publicize the initial studies.
I've
Yeah,
got a
send me
lead
that info if
canvas.
we want to. And you know what you could do? I mean, here's what comes to my mind. I mean, since you're an animator, you can do some amazing PR with animation for this, right?
Certainly possible. I mean, once we know what we're building. The big question mark that has arisen in the last 24 hours is reevaluating numbers, because the lolsbot mini is probably not viable. I need to evaluate the numbers for the TAS and try and make it viable.
Yeah, and the trick there is you have to look at what can you replace with just going about different way of sourcing. I mean, it really gets down to production engineering, and that's the hard part, because then you have to make a choice. Oh, okay, if I go some totally different way, which does not work for them because they're producing 100 or 1,000 at a time, but it would work for you because you're producing 24. You really have to go to that level. Like, you really drill down exactly how you want to do it to optimize for 24, 12, 1 to 24. Because you're not going to be able to get the both prices on certain things if you do that, so that's going to be a disadvantage.
Yeah,
but
Australia manufacturing here is a pain. It's like, if we can get anything working here with local manufacturing, then it can work anywhere. But it's actually really hard to do that stuff here. No one makes anything in Australia.
Right. And the other suggestion I might have, I mean, this is what I thought. It's like, you don't need to make that out of aluminum. What about if you use 1-inch or square steel tubing? I think that's also doable, and that would be much less expensive on the frame. So there's different. If you were going to get it to an amazing product, I think it might take some significant fiddling with it. But someone has to do it, and nobody has done this yet. Maybe the Caruza, maybe the Troublemaker is there, but it's also more expensive. Troublemaker is like, the bill of materials there. Well, it's about $1,000. It might be similar to the TAS. That's where the Delta comes in, where the bill of materials there is more like $500. Have you considered that?
No, I've not considered the Delta.
So we do have a good lead on that with Joshua Pierce of the Open Source Sustainability Lab at Michigan Tech. That's exactly what they're doing, and they're making the next iteration for their next version, because they're running workshops like that too already. But the trick to them is they don't have it appears to be a very difficult process in terms of replicability of the workshop, because it just takes so much time to prepare all the materials. So they definitely have some production engineering left to do, as far as I can see. But that's another great option. It would not be the same approach as here. It would be an open 3D printer typically, because it's one critique of the open printer is that it doesn't have the thermal control. Like I heard from so Musti told me that you really want to have the enclosed chamber, because then ABS printing is just much better. What did your guy say?
I've also learned.
What does Michael say about that?
Well, it certainly helps, but I also learned some other methods that we weren't using at OSE when we were printing in ABS, and that is that when you print, you want to make sure there's like a big boundary on the first plane around the actual object. We weren't doing this, and it's key. So when you've got your object, you need to have about an extra 1 or 2 centimeters of material on the first layer, and that helps stick it down to the bed and make sure that it doesn't peel up. Once you've got that, so I saw Michael doing ABS prints first shot. They were fine, absolutely perfect. So I think that's also another step that you guys weren't doing at OSE. But definitely an enclosed cabinet for temperature control does help.
I mean, it could be as simple as just a tube of paper. You just slip it around the whole printer when you print and just take it off or something. You know, just a big tube of paper, even, you know, around it so it keeps the temperature. Yeah. So I mean, as you see, there's a lot of detail to consider when you're going to get it to really a powerful force. It is a bit of development. Yeah.
And I guess the other question is, you know, the scaling is dependent on how many other people you find that can replicate the model. And, you know, I think that a big part of our success at this first stage is having such high-skilled people to help do it.
It is.
It becomes easier as time goes on.
Are you talking about Michael?
Yeah, that's right.
People like Michael?
Yeah.
Can't get a bigger team up front? Are you trying to reach out to people, or?
Yeah, that certainly helps. You know, if you can show people that they're going to not just, you know, get some basic education, but they're really going to have some ongoing support with people that really know what they're doing. That's something that doesn't really happen with 3D printers at the moment, so that's unique value as well.
And how do you get those people that know what they're doing? You mean the partners, the different people at the workshop? Or?
Oh, yeah, exactly. They're learning through Michael and other teachers
right.
involved. So they're getting deeper knowledge in an intensive boot camp rather than just buying a 3D print off the shelf, have it break on them in 2 or 3 months, and then they don't really know what they're doing.
Mm-hmm. Yep.
So yeah, I'm really focusing on making sure that when people come out of it, they've got much deeper knowledge than they would had they bought a 3D printer from MakerBot or whatever.
Mm-hmm. Absolutely. And that's the advantage. That's exactly it. It's basically you enable that printer to be a lifetime design as opposed to potentially a few months. Now, I must say that just about all the printers at Factory Farm, we have 1 out of 3 working right now, and it's because people just don't know how to use them. You know, they don't know how to troubleshoot it. Possibly.
We've got a few around here, but it would be interesting because I remember how many problems we had with those, and I would actually like to see Michael pick up one of those and see what he can do with it.
Interesting. That would be an interesting idea.
Because
do
I
you guys have
he would be able to get the performance out of it. Like he lives around the corner from me, and if you're interested in, you know, paying for some shipping here and back, I bet you he would be able to get high performance out of it, and OSE would be learning a little bit about what was going on with those things.
Mm-hmm. Yeah.
It would be good to send us your worst one.
Mm-hmm. Yeah. Yeah. So, potentially. So what? Yeah. What is your next step now?
Next
you got to look at more of the numbers.
Dive into more numbers, and
like bills and materials costs.
Try and get materials costs, and try to get the paths of the working model. If not, look at different designs.
Right. Yeah.
I mean, the other
Have
thing
you been
is
contacting?
when we're selling this, let's say we're selling these wild spots. We can't call them wild spots, can we?
No, you can't. You gotta call it your own.
We can say it's based off the wild spot design. It's just not an actual wild spot.
Right. Yeah, Yeah. Have you been talking to a lot of other people in the 3D printer world, or are you kind of working with Michael?
Another guy is Richard, who's a fabricator that lives in Coffs Harbour. He's also started to help us. He works for another organisation. He's allowed to occasionally cut things with CNC routers and stuff, so he wouldn't be able to run production lines for us. But he's quite a skilled machinist. He actually created his own triple head, 3D printed triple nozzle modification for his Cruiser i3, I believe. And I saw that thing in action, and yeah, he was printing with 3 different materials, which is pretty cool.
Yeah.
So yeah, we do
cool.
also have him as for some advice and potential machining of small things, not being able to run a production line. But he could certainly advise us on fabrication processes and
definitely
the best way of approaching those sorts of problems.
Yeah. So let's keep talking about this. And if you guys get far and at some point in the future, if we're ready for that, I definitely would suggest considering a workshop at Factory Farm, and then with the additional mission of distributing that enterprise to us. I mean, depending where we all are at that time. But yeah, definitely would be interested in seeing if that could potentially work. If we don't beat you to it, or if we don't work together on it more, something like that. It will be interesting to see different, even if, say, we go with the troublemaker, it'll be interesting to see what we learn from the different ones. I think it would be desirable to run perhaps different workshops, have that in our repertoire of skill sets, but at least definitely document the process.
Yeah, well, through our metrics, we could actually see what people want to do. We'd also perhaps be able to see what do they want to buy, because you could have on the website, I want to buy a printer, I want to build a printer, I want to build and buy a printer as 3 different options, and see
that's
ones
the right way to talk about it. Yeah. Yeah, that's great. I think that kind of a business model can be pretty powerful. It's like you choose what level you want to get into it, and that I think is very valuable. I think that could be a very successful business, because you got just so many options there. Yeah, I like it. Okay.
Our barriers
that sounds good.
Eventually, if we got to the point where we needed to fabricate over here, trying to figure out how to make that work, because we don't. As I said to you before, there's a potential relationship with a workshop that we could set up in Byron Bay, but the space it requires work before we could use it. So it's the relationship is slightly complicated, but it could be achieved.
Yeah. Right. Okay. That sounds good. Well, I'll get some facts tomorrow regarding what it means to make the troublemaker 3D printer. And you can look at that already on did I send you the link to that? I sent you the link. You can look at you can click on the electronics parts supplies and take a look at that, what the existing, they have a link in that to all the materials and how somebody's selling parts for that, so you can study all of that. I'm going to drill down into that tomorrow to see what improvements can be made, because right now it's a bit expensive. It's true. So imagine you can have a Delta that functions just as well, but is half the price. That's a very compelling reason to go with a Delta if it can have the same performance. So
okay, yeah, we'll have a look at that.
We have to really assess. What's the state of art in the Deltas? Are they actually getting the same performance as any other? The one we had at Factory Farm looked very good.
It may also be limited with the print head being a pretty limit. It's set in size. Changing the print head could be quite challenging on a Delta. So if you want to print in like double or triple material types,
why would it be so hard?
Gets quite a bit bigger. Because if you look at the way a Delta is usually designed, it's usually designed around the print head being a particular size, say a cube or a triangular shape. And if you were to start adding extra heads on there, it might become a challenge. Not necessarily, but something to be aware of.
Right. The advantage of the Delta is that it can be inverted for metal printing, and it can be supersized to do the house printing. Like, have you seen the WASP project? They're printing structures with Delta printers. Have you seen that?
The ones with printing out of clay and cement? Yeah,
that kind of stuff. Which is interesting. Now, those guys, it would be interesting to talk about. To me, that's actually quite interesting for building structures. Definitely interesting for building structures. I think there's, imagine you have a gantry robot that's printing your walls for your greenhouse, and then your walls are pretty much free. I think that would be a good idea. Between brick press, between extrusion of mud. Say what?
The machine would have to encapsulate the entire house if it would be built.
No, not necessarily. It could be a thing on a rail that goes back and forth. So all you'd need is a rail, or even it could be wheels on the ground, on a flat ground. So actually, it could be the same foundation. It just rolls on wheels next to the wall. There's different ways to do it.
If you've got wheels on the ground, repetition of movement would become an issue. It would have to be a rail.
Yeah, definitely there's challenges, but it's nothing that's insurmountable. Depends how you do. Because for one thing, there's super accurate GPS that's coming out down to inches resolution. So, that could solve all of that. Yeah. So anyway, lots of good things. Down the pike, the key is getting one product that's really robust. So I like it where you're going with this. Mm-hmm.
Thanks. I'll keep going.
Yeah, man. Okay, so let's call it a day here. Let's quit this call at 7:30. Yeah, we're good for now.
Yeah, all good. Thank you.
Yeah, and just keep me informed on how it's going, and I'll on our side with a 3D printer, so we can pretty much make a decision on that, which one we want to go. Because if we make a decision, then just go all out on that. Mm-hmm.
Will do.
But definitely, there's 3 good contenders, which is I guess a good deal. So we got choices.
And it could be quite attractive if you like the 3D printer university, not be tied
to
a build.
Yeah. Imagine you could choose the.
If they were all equivalent, if they were all kind of equivalent, you could cycle through builds, and you're able to provide locally to your country or to somewhere close any one of those models.
Right. No, that's right. I think. Yeah. Depends what you want, but yeah, I think the low cost absolutely has an advantage. That's the Delta. The Taz.
Question mark though. If it is low cost, I don't know.
If it is lower cost. Well, we do know the bill of materials for. We know the bill of materials for. We do know the bill is 500. That I do know, and I do know that the current troublemaker is about twice that. And
what was 500? Which one was $500?
The Delta, most Michigan Delta.
Is that the name?
So, it's called MOST, M-O-S-T, Michigan Open Source Sustainability Tech. MOST Delta. Look at Open Source Sustainability Lab. Yeah, look into that. I mean, the question is performance, but man, the one we had here was really good. Now someone broke the glass on the base, so got to replace that.
Okay, well, that's cool.
Yeah, it's sitting in my room, so I should play with that more. Yeah. Okay, well, anyway, so lots of good options. Let's see where the open source 3D printer, once again, to summarize that, this is unusual in that we're not just talking about producing, but we're talking about a distributed enterprise, which is one of a kind, which is nobody else is doing that. So I think it's a very worthwhile endeavor. All right.
Yeah, it would be cool if once you had like, the whole structure set up, the site could be replicated, and the whole structure could be localized anywhere.
Oh yeah. Oh, absolutely. That's the promising part, because then you can get support from many local places. You can say, hey, we've got this works. You'll be able to, to spread that many places. Imagine you go to a community and say, hey, we're going to teach you how to run a business on producing 3D printers, and we have a significant track record. I mean, that's something that anybody will take that. Everyone, I mean, 3D printers are just huge growth.
It certainly would be quite enticing to consider if you could go to the point where you're paying for the cost of parts, even sent out in units of 15 from China. If those parts are coming from there, if you could price it so that you are always undercutting the competition, that should be the goal as well. To try and make sure that your printers are always a bit cheaper than the competition if they're buying them from overseas. Then you know that you're competing.
That could be, but could be. But I don't think it's about competing with price as much as the service, right? But the price would be nice too.
But in the end, you do have a product that you're selling. So even though you've got the educational model, that's the unique value. But
right.
If in the end you're selling your printers to the site, then they have to compete.
Right. And that would be a worthwhile thing to do, and I think could be possible. Definitely.
It should be if we're acquiring parts for the same prices as, or close prices to those, provided, and considering our workforce is paying us.
Oh, exactly. With that absolutely. In that model, however, the question is going to be, you're assuming that the prices will be similar, and that may not be. In order to do that, that would take some work, right?
Yeah. Have you ever looked at those startup helpers over in Shenzhen, China? Have you ever? I remember you posted something on your wall.
No, definitely. There's a great one, Accelerator. Yeah.
Have you actually connected with any of those guys? Because
talk to them briefly.
At some point, seems like at some point it might be, it might be where things start to go.
We could do that for a 3D print project, but other things like the brick press, they weren't really into that.
I mean,
I emailed them about the brick press.
Imagine if Open Source Ecology actually had someone on the ground in Shenzhen, China, to help you find parts.
It would be great.
Everything you need to make something is there. It seems like
absolutely. I mean,
having someone on the ground find stuff for you is what you need. Like, it helps you sort out distribution. It helps you get things for the right price, and they can. It could even be the beginning of a new business model for you, because you're saying, we're open source, but hey, I mean, these parts, you can get them from here cheaper than anywhere else, and we ship them to you.
That's exactly right. That's doable. It's worthwhile. I think that's a good idea. But eventually, if we get the techniques for producing things from raw materials, then nobody can beat our price wherever we are, right?
Yeah, but that is quite a way away, don't you?
We're not. It's quite a way away, or quite short if the acceleration of development happens in an amazing way. But no, we're not there yet. So the biggest power punch is getting the development techniques to be so refined that we can, like we're experimenting with the aquaponics group, so refined that the production time, the product development time is just radically decreased, and then we can knock off all these things one by one. That's my goal, trying to get that infrastructure in place, and it's hard. But there's a lot of good stuff happening. I just talked to another guy today on, they're actually doing product management, open source product data management and workflows for open hardware development. There's an effort, a consortium starting in Europe. This guy was from the Technical University of Berlin. So there's a lot of different activity going on this, and hopefully if these guys pull through and we develop some more open tools for some of the critical aspects that are missing, I think we are going to hit that point where open hardware development, I mean, it should be like you conceptualize something in days or weeks, you got a product, not months or years.
Actually, on that note, there are two things that came up to me that I thought were very exciting. There's a developing, it's like a PCB software dev tool that was previously high-end, and I'll get the name for you, but I believe that they're making a free version of their software, but it's all cloud operated. And if you use the free
for
version,
which?
everything you
do. For PCB design?
I'll find the name. Yeah, for PCB design. If you use the free version of the software, it's fully functional, but all your designs must be open source.
Yeah, I know that one. It's called Upverter.
No, this one's different. It's definitely not Upverter.
Different?
It was previously very high-end and expensive, and they're basically saying, well, if you want to use our software for free, it'll still be, almost top tier, but all your stuff has to be open source and on the cloud while you're using it. Now, imagine if you could pitch that concept to someone like the makers of SolidWorks or Autodesk to say, look,
right,
if you could actually give people free versions of your software, but all of their output is open source and on the cloud, then everyone benefits. If we could get a 3D software company like Autodesk or the makers of SolidWorks to do the same thing, that would be a massive acceleration and solve a big gap for us.
You're right about that. Yeah. That could help a lot. I think it's probably... The attractive part is that could be an immediate solution. The not attractive part is still you don't have a lot of control over what you can do with the software if it doesn't have the right feature.
No, that's true, but at least it gets you high-level software for people to use and collaborate with, where currently we have zero.
Yeah. No, that would be interesting. Okay.
So free marketing for those companies.
Yeah. No, they might be convincible. Okay. I got to get going here though, but good conversation. And let's keep in touch on the progress of how this goes.
Sure, pretty much it.
Okay. So thanks a lot. And so this will officially end our True Fans Hangout. And we'll
just one more quick question.
Go ahead.
Aquaponics. Now, if I have local people here locally that want to keep in touch and collaborate with that, we actually do have an 8,000 litre aquaponics system where I'm living. So it's certainly, I'm very interested in keeping up to date with what approaches you guys have when you figure out all the communication things.
Okay. Right now, if somebody wants to collaborate on a team, there's our sign-in. There's just a survey, the collaborator survey. So if someone wants to join the team, just fill out that form there.
Sure.
Sorry, capturing the sign-up. That sounds good. Let's see what we find out here. Excellent. Okay, well, so let's call it that. Thanks for participating, and we'll talk again, the official True Fans Hangout next month. Thanks a lot.
All right. Thanks much.
Thank you. Bye-bye.